Hello, hello, hello. Welcome to another day of LeetCode Live daily streams where we do a lot of LeetCode in hopes that we continue getting better at it every single day. If you're new here, if you're watching for the first time, and if you like doing LeetCode, you like problem solving, you like learning about data structures and algorithms, make sure to click on that follow button on Twitch, subscribe to me on YouTube, and if you're feeling really good, remember to ring that notification bell so you can always be up to date with all of my streams. I have been posting every single day without missing a single day since July, since July 16th. So you can almost be certain that I will always be around to stream. So we're one question away from 200 questions, a phenomenal achievement, one that I've actually never gotten to, which is pretty amazing. I'm very happy to have made it that far. I mean, I've definitely passed my proof of concept step. So without further ado, let's go ahead and keep going on our journey here. Let's get to 200 questions. We're going to be resuming on page 3, and we're going to be starting from, I think we tried to do this one yesterday, but let's figure out this one now. Maximum ascending subarray sum, starting off really strong with a very high quality question, it seems like. Let's see what this one has in store for us today. So, given an array of positive integers nums, return the maximum possible sum of an ascending subarray in nums. A subarray is defined as a contiguous sequence of numbers in an array. A subarray is ascending if for all I where I is greater than or equal to L and less than R. Note that a subarray of size 1 is ascending. So let's see, and they want the maximum ascending subarray sum. So let's kind of like think about, I want to draw this out. I think this would be a good question to draw out. What I'm going to do, I'm going to get my text tool. I'm going to draw this out, expand this. I kind of want to go through all the ranges where we know it's ascending, right? So if we get our marker here, make this a little bit thicker, give this like an orange color. All right, so 10, 20, 30, it's increasing here. It's also increasing here. And it's increasing here, it's increasing here, and it's increasing here. So this is like all the different arrays where it is increasing, or subarrays, I guess. Now, which one of these offers us the biggest value? Like if we do 10, 20, and 30, right? Just imagine we do these three, that's 60. These two is 50, one here is 30. If we do this three, it's 65. If we do this, it's 60, or if we just do it, it's 50. So I would say based on what they want us to do, the answer should be 65, right? Yeah, 65. 5, 10, 50 is the ascending subarray with the maximum sum of 65. So I wonder if like, could this be, I don't want to just say like, I can't just subtract anytime I get to a point where it's descending, right? What if we had 10, 20, 30, and then we get to 5 and we're like, okay, well, maybe that is necessarily the longest one, right? Maybe the longest one is just how long can we keep going till we reach a point where we're descending and then we reset again and add this and keep going all the way. Does that always work? Like for here, all these are ascending, so we add them. Let me try this one without even, well, I see the answer is 33, but now I want to actually try and come up with that on my own. Let's again increase this and let's see what we have here. So imagine we start this way. We say, okay, 12 and 17, that's cool. Now this one's lower, so now it's 15 here. Now we go 15 to 13, this is 13, this is lower, right? So we start at 13 here. 10 is lower, so we start at 10. 10, 11, and 12, that's what? 10 plus 11 is 21, plus 12 is 33. So I think our algorithm can be that as long as the number, right, the next one has to be like strictly greater than the previous one. So anytime we get to a number that is less than the previous one, we just reset it and add that one. We essentially just reset it to this and keep going. So we can keep adding as long as the previous one is less than, strictly less than. And I think that could be the answer. So let's write sum here. All right, so for let I equal 0, I less than nums.length I plus plus. Now if I equal to 0, I feel like that's a special case. If I is equal to 0, or let's see, nums of I minus 1 is, right, so this one is greater. If it's greater than nums of I, then we set the current sum equal to nums of I. Else, sum plus or equals nums of I, return sum. This is sort of what I'm thinking so far at a high level, but I do want to try it for all these different ones. So we're at I right here, right? So if I is equal to 0, already that's the case, so sum is just equal to 10. Now we come here. So it's not equal to 0, nums of I minus 1 is not greater than this, so now we could just add the 20 here to get 30. Come over here. The previous one is not greater than, so we can add 30. Okay, that's 60. And now we come to 5. Now, anytime we come to 5, here's actually one thing that I did not take into account. We should also have the max sum, right? We can set this equal to 0. So before we reset it, we should set max sum equals to math.max of max sum or the current sum. So right here, the previous one is greater. So now max sum becomes what? 0 or 60. So this is 60, and now sum becomes 5. We go, right? Not 0, previous one is not greater. This is 15. Not 0, previous one is not greater. So this is 65. Right, and now we're out of here. Now what happens? I think we have to do the same thing again. We should also now consider return math.max of max sum or sum. Because look at this case right here. Sum is greater, but since we never, like, had I just returned, well, I guess in this case, the sum would have been the same, but I feel like there might be an edge case, because I've seen this pattern quite a lot in LeetCode. So I think for, just to be safe, we can just do this. I kind of just want to run it and see what happens for all my different test cases. So 65, 150, and 33. Okay. So let's see, because we definitely just went over this, right? So I think this is going to have to do with one of these being the same. But let's see. So we're going to start both of these. Oh, of course. I did not start both of these at 0. Let's comment this out and let's run this again. 33, 33. Will it run? Let's see. Okay, interesting. 3, 6, 10. So we get to another case here. This should be contiguous, so you know what it could be because these now are the same. So I feel like the issue here, because it's saying it's ascending for all I if I is greater than or equal to. So if it's the same, it's still ascending. So only if it's greater, so that should be fine. Because it should be 3, let's see, we're here at 3, sum is equal to 3. We get here, sum is equal to 9. We get here, sum is equal to 19. Now we get to 1. So here this becomes 19, and now this becomes 1. Now we get to 8. That's 9. Then we get to 9. That should be 18. Then we get to 9 again. Let me see what I did here. The answer I gave was 27, but what? Does it not like? Should it just be? Well, let's see. What happens if here, this is not, the previous one is not greater than, so we're going to go ahead and add it, 27. Now, if we don't do that, if we don't go ahead and add it, then we'll do max sum of max sum. So that stays the same. Now this is reset to a 9. We come over here. Okay, the previous one is greater. So what? We reset it to... Ooh, this is interesting. How are we getting the 19 here? Am I just not seeing this right? Because 1 plus 8 plus 9... Oh, is it coming from... No, because that would be 9 and 9, that's 18. 9 and 9, that's 18. 9 and 8, that's 17. 8 and 9, that's 17. 3, 6... Oh, 3, 6, 10, which is max sum or the current sum. And it just wants the maximum ascending subarray sum. Yeah, wait a second. I think we... Oh. I think we should reset it if it's equal. Maybe that's the case here. Let me do this. Let's go ahead and run this one here. Let's pop this into our test cases. Oh. $65, 150, 33, 19. Okay, let's run this. Okay, 87.76. Pretty cool. Let me go ahead and check my YouTube just to make sure everything is good. You know, like recently, well, yesterday, let me just make sure. You know, like recently, well, yeah, yesterday we had some issues with like frame drops. So actually, you know what I should have done? I should not even leave. I've been trying to tweak like, so what I did in the beginning was I tweaked my Streamlabs settings to be like as best as possible, but I guess I have a computer that's not as beefed up as newer computers. My machine's 5 years old, and even though I take care of it, there's probably some better hardware I could be getting, and because of that, it sometimes causes like frame drops and things like this. So I'm gonna leave this here, and then we can look at that whenever we need to. Okay, so 87.76. Pretty happy about this. If we think about the time and space complexity, the time here will be linear since this is like linearly proportional, directly proportional to the size of nums, right? However long nums.length is, it will have to iterate through the entirety of that nums array. As far as our space complexity goes, it's constant since we're only having to keep track of 2 variables here. So yeah, feeling really good about this one. That's awesome. Hey, Liben Jama. That's awesome. Yeah, thank you so much for telling me that everything is good. It's always nice to hear, especially from the people watching, because I feel like I'm still fairly new to the streaming game, and sometimes I just don't know. Like sometimes I feel like I can't trust my tools, but I need to learn how to trust my tools. So thank you. And I think for some reason I feel like I've seen you before. Apologies if you've been here, and I probably actually already gave you a shout out in like a previous stream, but if this is your first time here, thank you so much for joining. I hope you're finding all of this very useful. Cool. So let's all give ourselves a pat on the back because we just got to 200 questions. So what does that mean? That means if you have followed me since day 1, since day 0, we're now sitting at 200 questions. So very, very good stuff. Now let's get to on the road to 300 questions. Can you believe it? I honestly can't. I've never done that many. All right, 3 consecutive odds. All right, so actually I do want to save that previous question. I think it is good. Okay, so given an integer array, return true if there are 3 consecutive odd numbers in the array, otherwise return false. Really? I think what I can do, I really just want to check from 1, like there can only be 3 consecutive odds. Like if I get an array that's of size 2, then I know that's not the case. So I need for it to be at least greater than the length of 2. And we're saying we can get one that's greater. We can get an array that's length of 1. Oh, Peter Parker, look at this. This is new people. This is awesome. I use Java for LeetCode and never have used JavaScript before, but the syntax looks extremely similar. Yeah, a lot of these languages, some of the times syntax is pretty similar. What I always try and tell people is don't memorize syntax, memorize concepts. What do I mean by that? Like, don't worry so much about learning the syntax of a language, just understand high-level constructs like how do I create a list? How do I iterate over a list? How do I create objects? Is there support for classes? How can I create classes? How can I store information? These are constructs that are universal across any language. So I think at some point, the more senior you get in your career, I think it's better to think in terms of big building blocks instead of, very like precise language syntax. So I think because of this, if r.length is less than or equal to 2, then we return false. Else, I think what we can do is just say for let I equals to 1, I less than r.length minus 1, I plus plus. If we just have to compare 3 of them, right? So I'm going to kind of like break this up into a bigger if just to make it easier to read. If r minus 1 modulo 0 is equal to 1 and r of I modulo 0 is equal to 1, and r of I plus 1 modulo 0 is equal to 1, return true. Else just return false. I think this is the way that we could do it. I feel good about it. Let's go ahead and see. False, 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 true. That's awesome. Let's see where we went wrong here. Let's think about, okay, so, I mean, I got the first one right. The second one should have been true. Probably something like really dumb I'm doing here. So ri minus 1, r of I, and ri plus 1 equals 1 equals 1. 3 consecutive odds. Here it should be what, 5, 7, and 23. Okay, so we should definitely make it there at some point. Let's see, if r dot length is less than or equal to 2, no. We start here at 2. Okay. I less than r dot length minus 1, and this is r. So we should go up all the way. 5, 7, and 23. We should end up here. So what am I missing here? If r at I minus 1, which is 5, modulo 0 is 1. Wait, oh my god. Modulo 0, come on. Can you believe that? Classic. Little mistakes. False, true, false, true. Let's run this. 57.78. Now there's something I want to try. There's one thing I want to try. Yeah, that's why it's good to like, what's up, Rashawn? Always good to see you, man. Always good to see you, Rashawn. That's like one thing that you should be doing in your interviews is definitely, like, you see how I went over, like, I thought, you know, what I should have done is I should have gone through it first before ever clicking submit to begin with. I probably would have caught this. But you see how I kind of like tried to go through it and debug it myself. So that's definitely a good skill to have. I want to see if I can like make this a little more JavaScripty. So I think here I can do r.sum. Let me see. So sum is a pretty cool method with arrays. So it says the sum method tests whether at least one element in the array passes the test implemented by the provided function. And the nice thing is if it finds an element for which the provided function returns true, I think it automatically just returns true as soon as it finds the first element. So you don't even have to go through the entire array, which is kind of like a nice optimization. Okay, so we have element, index, and the original array. Oh, absolutely, man. So we have element, index, and the original array. So I think with this, I can just essentially return this. And don't worry, I will format it. I know it looks crazy right now. And instead of here, yeah, we'll have to do index here if I want to do it like the exact way. And I could just kind of put this on this line, put this here, put that there, index, index. Okay, so that's that. Sometimes it's like hard to see this. I think that's good. We have this one. We have this in here, which corresponds to the arrow function. I think this should work. Let's see. False, true, submit. Nice. Yeah, this is a very nice like array method in JavaScript. There's sum, and then I feel like the cousin of sum or the sister of sum would be every. Every makes sure that every element in the array passes, and as soon as one does not return that thing, then it just returns a Boolean value. So it's like pretty nice. Definitely know how to use this API here. Every, yeah, every's awesome. Every's very cool. Cool, yeah, I really like this question too. Yeah, so far I think we're off to a great start. Some nice questions we're tackling today. All right, so number of 1 bits. Wait, I feel like we've done a lot of questions like this. Write a function that takes an unsigned integer and returns the number of bits. Okay, well, if this function is called many times, how would you optimize it? The input must be a binary string of length 32. I mean, I think we know how to do this. This is the, yeah, this is literally just a formula I've memorized. So we can say, and I wonder if, can we reduce that number? No, because reduce only works on an array, right? But we can say let bits equal 0 while n, we can say bits plus plus n equals n and n minus 1 return bits. Yeah, I mean, if you're looking at me doing this and you're thinking like, wow, he like just figured that out so quickly. I'm not like a genius or anything. I just memorized this algorithm. This is like such a common thing. I just memorized how to do this. Exactly what they said. It's called Hamming weight. And I'm guessing, I wonder if here, because right now I feel like maybe this is the answer, because you could come up with an array, or not an array, but you could come up with a algorithm that goes through every single bit and just checks to see if the bit is set or not and count like that. But then for every unsigned integer, they're saying it's maximum 32 bits, right? You'll be doing it like 32 times, which is, it's constant, right? But if you have like 1,000 numbers and you do 1,000 times 32, that's 3,200. Right? Whereas if you have, right? No, that's not 3,200. That's 32,000. What am I talking about? If you have this will only run for as many times as there are set bits. So now you've effectively decreased, like this would always run 32 times, but now here we're only running 3 times since there's only 3 set bits. So I want to think that that's the optimized answer. Even though they're both still constants, a constant of 32 is not the same as a constant of 3, especially if you're dealing with this many times like they're saying. Everything at scale is different, right? Let's see if discussions have to say anything. Yeah, there you go. This one, I'm curious why they do this. 1s equals 1s plus n minus 1, and then they shift it while n is equal to 0. C plus or equals, here's my solution, n and n minus 1. Yeah. What are the replies here? Nice. It's a Brian Carnigan's algorithm. I think it's Brian Kernighan, but that's fine. Yeah, I think just using this algorithm makes it a lot faster. So, by the way, one thing I did change, and let me check, everything seems good. For the people that are watching, you know, if you all watched yesterday, I was a little bit nervous because there was like the frame drops at the end, and then YouTube took like a couple hours to bring the stream back. So one other thing I did was I dropped the frame rate to 30 frames per second. So for people that are watching, is it a noticeable difference? Is it annoying to look at? Just let me know what you all think. In the meantime, let's get to the next one. I think we've done we've done 4 questions. This is going to be our 4th question. That's great. All right, so you're given an array of unique integers salary, where salary I is the salary of the ith employee. Return the average salary of employees excluding the minimum and maximum salary. Why do I feel like we did this one already? Haven't we already done these? Return the average salary of employees excluding the minimum and maximum salary. Okay. So it's just 2,000. I mean, I can find out the min and max. That's a linear time operation. I can do that twice. And then at the end, for any number that's not that, and then I have to go through the whole thing again. I mean, it'd be nice if I didn't have to. I mean, I feel like we can just do const max equals math.max of salary, const min equals math.min of salary. Let sum equals 0 for or we can do for const s of salary. Let's see, if s is not equal to max and s is not equal to min, then sum plus or equals s, and then we just return sum divided by salary.length minus 2. Oh, but I think it wants me to floor it. Return s, oh, sum. Okay, I'm not sure what happened there. I think it wants me to floor it though. 2498, is that? Yeah, let's see. Although I don't really know if that. $2498, wait. The maximum, so 3 plus 2 is 2.5. Why do we get that? So the max is 4,000, the min is 1,000. If s is not equal to max, oh. Right? It's always like weird. If s is not equal to max, if 4,000 not equal to max, that's false, because it is equal to max. Or do we just want like one of those needs to be true? I only want to add it if the number I'm on is not equal to max or not equal to min. Still getting the same thing. If s is not equal to max, 4,000, that's false. Or, yeah, but then we also, it needs to be why are things like this like so complicated sometimes? Like it's literally just like a simple expression here and that thing's just like tripping me up. I bet you sum is going to be some crazy what are we getting for sum here? Sum.salary.length divided by 2. 10,000. Beautiful. If s is equal to max or s is equal to minimum, I'm going to do something just like gross because I realize that we can do this better, but let me just see this real quick. Then what's max and min? Maybe I didn't do that part right. Could have sworn, oh, you know what I might have to do? I don't know if I can just pass an array. It has to be a comma separated list, no? Obviously. All right, I think I was going crazy. I know why. This has to be a comma separated list. So we need to spread the elements of these arrays into those functions. Console.log max and min. Okay, 4,000, 1,000. And I want to divide it by, I think I know what's happening here. Salary.length divided by, no, salary.length minus 2 is just going to give me the same number. If I do 4, that's 5,000. Minimum salary and maximum salary are 1,000 and 4,000 respectively. Average salary excluding the minimum. Right. 2,000 and 3,000, that's 5,000 divided by 4. 5,000 divided by 2, no? What are we missing here? This has got to be wrong here. I don't want to do anything if S is equal to either of these numbers. But I could do something if it's not equal to max or not equal to min. So if 4,000 is not equal to max, which is false, or 4,000 not equal to min, obviously I'm having issues with very simple things right now. Classic example how this, oh wait, okay, yep, false. 4,000 not equal to 4,000, that's false. So should this be an and? And this thing doesn't need to be a math.floor. But then this is weird because it can't be, yeah, no, it can't be either, right? So why wouldn't this, okay, maybe that's the piece. Maybe that's the piece. Let's see. Wow. I'm honestly just like so perplexed right now. If S is not equal to max, do I need to do like an XOR or something? Because if false or false, if I do and is F, no, but this will be false, right? So we'll add this one because it's not going to be either. But maybe 1 or 0. What if we do this? If S is not equal to max, XOR S not equal to min, for const S of salary, am I really gonna have to like average salary of employees including the minimum maximum salary answers within, wow. Someone that's watching, please give me the expression for this, because obviously I know how to do things with like number of 1 bits and Hamming weights, but simple binary expressions I cannot come up with, apparently. So let's write a truth table, right? Let's write a truth table where like 0, what do I want this to be? 0, 0, 0. Maybe that means add it if the number is not either of them. So does that mean I only want to add when I'm here? Because if either one of these is true, then I don't want to do anything. So what's the truth table for that? Constant math, okay. Const sum salary reduce a plus b 0 return a plus b return sum minus min minus max divided by salary dot length divided by 2. No, that'll definitely work. Like I can read that right now and definitely that will work. But I want to figure out why this is not. What is only true if both of them are off? Or I guess, what if it was the other way around where, no, yeah, is this even a thing? Like imagine each one of these bits is one of these conditions where it's either max or min. We can either be looking at one that's a min, we can either be looking at one that's a max. Well, we can never have one that's a max and a min, right? It's going to be either or. So either the number's not going to be a max or min. So I guess there's really only 3 decisions to make here. It's either going to be not max or min, or there's going to be 1 min or a 1. I did do that, but maybe it's just like something. Oh my god, that's so funny. If this returns true, right? It should be this, because unless it's the opposite, if this returns true, don't do anything. Maybe it's the not of this. This is getting crazy. It's getting crazy. Let me see something real quick. Oh my god. Sum, if not, if S. Oh wait, if S is equal to max or S is equal to min. This is incredible. Let me see, 38 minutes. Okay, we'll spend like 2 more minutes on this, because there's obviously something very simple I'm missing here. I just need to go through this and only add to sum when the number I'm on is not one of max or min. That's so weird. Because if you say it like that, right? If S is not equal to, maybe it's because the or, do we need like 2 of them? If S not equal to max and S not equal to min, what was I doing? If S, isn't that what I had? Wait. If, right? Yeah, if S not equal to max or S not equal to min, pretty sure I had this earlier, then we just sum it. You see, why are we getting 2498? And then check this out though, like if I console.log sum, we get like 10,000. Oh, and let's see. I could have sworn that was like one of the first things I did. But then wouldn't that mean that for numbers that it's not? Okay, yeah, that's 5,000. And why am I not getting 5,000 divided by salary.length is 4 minus 2. Does it have to be rounded up? Really though? But sum minus min minus max? Maybe, hand sanitizer. It might have to be, but return sum divided by salary.length minus 2. Oh, wait a second, man. Is this frickin' PEMDAS? Oh my god. Guys. That's... Oh my god, that's... Wow. Okay, I think this has to go down. Okay. This right here is like, man, maybe I'm tired or maybe I just forgot how to do like everything. But man, this PEMDAS thing, yep, that's exactly what it was. Wow. Man, I spent way more time on this than I really wanted to. But let's think about this, right? Each one of these is a linear time operation, and this is a linear time operation. So it's O of n with constant space complexity. Now, I almost guarantee you there's a faster way of doing this. For some reason, I have a feeling there is. A one-liner. Note the conversion to double. Okay, well, this is some crazy stuff. One pass. Okay, no, they did pretty much the same thing. Oh yeah, look, they came up with the solution you had, Rashawn. Okay, well, that was embarrassing. That took me way longer, but it's okay. We're gonna keep moving. And I think, you know what, to be fair, I think that was actually that was a decent question. I'm gonna add that one too. Transpose matrix. All right, so given a 2D integer array matrix, return the transpose of matrix. The transpose of matrix is the matrix flipped over its main diagonal, switching the matrix's rows and column indices. All right, well, anytime I see this right here, yeah, no, the salary.sort thing is cool, but then that makes it go from linear to n log n. So Awesome, man. I really love to hear that you love the streams. It makes me happy to hear that you love the streams. And that's why I keep doing them, because I've been learning a lot, and I hope you've all been learning a lot. So just keep it going. It's tough, like to get people to transition over to like this method. A lot of people are trying to do like grinding, which I understand. There's always going to be room for grinding, and there's very good resources for that. But, I'm trying to offer something different where it's not so much of a grind. It's more of like a methodical approach to getting better at this stuff. And hopefully people can gain value from that. But let's think about this one. I'm going to see what every new cell becomes. So what I'm going to do is I'm going to just write out like, okay, so we're on row 0, right? We have 0, 0, 0, 1, 0, 2, and we have 1, 0, 1, 1, and 1, 2. We have 2, 0, 2, 1, and 2, 2. So what do these all become? I am going to put this on every single line. Okay, so 0, 0 stays as 0, 0, right? I think it's way better. Hearing you speak out loud and work through the problem is super helpful. That's awesome, man. That's so cool. That's exactly what I aim to do. So, all right, 0, 1 becomes what? We go from 0, 1 to row 1, column 0. And then row 0, column 2 becomes row 2, column 0. Okay, 1, 0. Row, wait. Row 1, 0, or 1. Okay. Row 1, column 0 becomes row 0, column 1. Row 1, column 1 becomes, actually that stays. Then row 1, column 2 becomes row 2, column 1. Okay, now row 2, column 0 becomes row 0, column 2. Row 2, column 1 becomes row 1, column 2. And row 2, column 2 stays as 2, 2. So I think one thing I've noticed is like all the 0, 0s, all the ones that are the same stay in the same spot. That's like one thing we can sort of go through. Now, something else I've noticed, actually I just realized the pattern. And I don't know if it's going to be like that easy. And I'm sure there's like two things, right? There's one way that we can do it in place, I'm sure. But look at this, right? We're just going 0, 0, 0, 1, 1, 1, 2, 2, 2, and this is 0, 1, 2, 0, 1, 2, 0, 1, 2. So I mean, can we start, if I just start moving things around though, I'm gonna be, how do I say it? Like, I'm gonna be overwriting other values. So I think one thing that we can do, if not to do it, let's try to not do it in place first by just creating a new array, and then let's go from there. So what's always like a nice way to do, like, I always forget of like nice ways to do create 2D array in JavaScript based on another one. There's always like some nice solutions here. No, is there like an ES6 sort of way? 2D dimension, r.fill map, from map, new array, map, nth array, from array n. Is there like another? Okay, push value. I don't want to do that. I guess we could do something like this. We'll have to agree with hand sanitizer. I also like the live streaming aspect as opposed to a 4-hour video of someone doing LeetCode problems. Nice, that's awesome. Yeah, I try to keep these like, I feel like 1 hour is good enough where it's not so long where if you think about having to do it every day, you're like, oh man, I gotta do like my hour of LeetCode. you know. But I feel like if it was half an hour, maybe that's too short. I feel like an hour is just like the right sweet spot where it's long enough where you learn, but it's also short enough that you can still like keep your sanity. So let's do this. I want to create, this is a, okay, so it has 2 dimensions here. So let's create an array of matrix.length. Here we'll fill it with 0, and then we're going to do the map where each one should be matrix of 0.length dot fill 0. I guess we can do this. Let's try that out. And then we'll call this grid. And now what I think I want to do is just really just do this, right? Do exactly what's happening here. We can say for let row equals 0, row less than matrix dot length, row plus plus. For let column equals 0, column less than matrix row dot length, column plus plus. And now you have to mind, we have to look at the differences here, like 0, 0. Oh, wait a second. Is this? Let's see, like 1, 0, 0, 1. Okay, wait. Because what's going to be 0, 0, 0, 1, 1, 1, 0, 1, 2. Oh, no, wait. It's just the exact same the other way, right? So in the new place, like let's say in matrix, I think here we should do matrix of column row equals matrix row column, right? Because here, this is like going in row column, right? But this is going column row. And here, this should be grid. And then let's just return grid here. I feel like this should give us the answer. 147.258.369. Let's try the next one. Nice. Okay. Where did we go wrong here? Probably trying to... So I wish... Okay, this only ran for both of my test cases, and this is undefined. Okay. So what would that be? I mean, I'm still getting the same... Oh, okay, okay, okay. I see. Because here, like, there's more columns than there are rows, so I have to be careful. Because this can be, I mean, if I'm just doing 0, 1, 0, 0, 0, yeah, I'm going to want to go through each one. So probably what I should do, in our second loop, do we need an empty array? In our second loop, do we need an empty array? I'm not sure what you mean by that. If we need an empty array in our second loop. I think the issue here is that row should... Yeah, let's think about this. Matrix row dot length, but here in column, that's probably the gotcha right there, right? If it's a 3 by 3 matrix, it's easy. But then if it's a 3 by 2 matrix, 2 rows, let's actually just do it here, right? So we're going to have how many rows? We're going to have 0, 0. We're going to have 0, 1, and 0, 2. And then we'll have 1, 0, 1, 1, 1, 2. Let me just copy this. This will just become the opposite, right? It should be 0, 1, 2. 0, 1, 2. But I guess the issue here is that this only has 2 rows, but now I'm accessing this other column here. So it might not actually be, maybe that's not the pattern. 0, 1, 2, 2, 2, 2, because that could be 0 and the columns could be 1. So there must be something else that we're missing here. Oh, wait a second. Yeah, no, okay, I think I see what you're saying. Maybe 1, 4, 2, 5, 3, 6. So yeah, we are creating, it looks like we're actually ending up with more rows. So do we like create our columns first and then append that to our result? What if we were, would that still work? 1, 2, 3, 4, 5, 6, 1, 4, 2, 5, 3, 6, 1, 4, 7, 2, 5, 8. Wait a second. If you also look at like the output here, you notice that like it's just going, it's just taking every single thing in. Yeah, wait a second. I think we have, for every row, declare empty array, push column into array, push array into results. Okay, what does all that mean? I don't even think we need to do anything with, I don't think we need to create a new grid, but I understand what you're saying, Rashawn. So let's actually create a new array called transposed, right? Because check this out. Like if we look at this, 147 is what? Column 0, column 0, column 0. 258, column 1, column 1, column 1. 369, 369. 1, 2, 3, 4, 5, 6. 1 and 4, we just take 1 and 4, 2 and 5, and 3 and 6. So I think what we just need to do is go through each column in every row. Right, for every row. And what will be a nice way for me to do that without having to like, it'd be nice if I can just move like all together at the same time. But how would I get everything in all the rows? I think we need to actually, we can do for columns. Okay, I think I have an idea here. I kind of want to do something where I'm like scanning. I'm scanning from left to right. Let's draw this on Excalidraw. And I think it'll make a lot more sense. So what I want to do is if I have this, let me make this larger. Right, like I just want to scan. I just want to scan and go through like each. Oh, I guess I can just actually draw a separate. Make this one bigger. Okay. All right, let's say this is our line. Like I want to get all these numbers first. Then I want to get all these numbers. Then I want to get all these numbers. So for every column, I just go through all the rows. So I think that's what we should do. Okay, I think I have an idea. I think I know what we can do here. For every column, we go through all the rows. So here we can say for let column equals 0, column less than matrix of 0, dot length, column plus plus. Here we can say new transposed row. Then we can say for let row equals 0, row less than matrix dot length, row plus plus. Here we should just be able to do new transpose row dot push. Let's see, and this is just creating, yeah, we can just push the thing at matrix row column, and then transposed dot push new transposed row, and then just return transposed. For every column, we go through all the rows. We're always going to be starting at 0, but on that column, I think that could be it. Transpose, probably spelled that wrong. Okay, let's see. Do I have all my test cases? Okay. There you go. That looks good. 24.73. Okay, nice. Yeah, that was a really good hint. And I don't even know if you intended to make that a hint, Rashawn. Maybe it was just probably like a thought. But no, you're right. Like we drew the first thing, which we were making pretty good progress, but we forgot that when we're transposing it, we have this case where since we're essentially flipping the rows and columns, we can end up in an out of bounds situation. But then here, as I was looking at the output, I was like, wait, 147 is just like these indexes here. So for every row, we can just go through the column we're at, or just push the thing at the column we're at, right? So it's like for column 0, go through all the rows, adding the thing at column 0. At column 1, go through all the rows, adding the thing at column 1. At column 2, column n, right? We just keep doing that. So that seems like a pretty good way for this to go. And I'm happy with this solution. Like, it's way more concise than my previous one, right? This will still be n squared because we do have to go through all the rows and all the columns. Right? For every column, we go through all the rows, right? Or this will actually be m by n, since we know it's not a square. And space complexity here will be constant. Copy directly. Let's initialize a new matrix. Transposed. For C, answer of CR, whatever that is. This is what we tried to do before. RC, answer CR equals ARC. Oh, so I guess this is closer to what we did in the beginning, which it still looks like almost similar to what we did earlier, but simple Python, posted solution can work. That's cool. Nice. I'm very happy with that. I'm very happy with like the stream today. Hopefully, again, I don't know if you all heard me last time, but how's the 30 frames per second? This 30 frames per second like been all right for you all? We're about to hit the 1 hour mark, so I will keep this to an hour, but we did a lot of questions today. We did like 5 questions. 204. Yeah, we did 5 questions, which is like very good. We started at 199, so we are over the 204 mark. So I mean, give you guys need a round of applause. Round of applause. I hope it's Shia LaBeouf. I want to see Shia LaBeouf. Come on, Shia. There you go. This one. I like this one. That's how you all should feel right now. There you go. Oh, it doesn't loop, really? Round of applause for everyone on the stream. You all made it. We all made it to 200 questions. It's not an easy feat. It's been a while coming, but we did it. So I'm very happy about that. 200 questions solved. Can you believe that? I mean, I started this stream. Let me give you guys a little bit of history for anyone that's watching right now. I started this. If we go to my channel here, we go to playlist. I try to keep everything to LeetCode Live easy collection. General bits and bytes. Let me just make sure this is only, okay, cool. LeetCode Live easy collection. This has every single video since day 0, which was, July 16th. So, I mean, on this day, like if we start, it's pretty freaking crazy to look at this. I mean, I haven't actually looked at video 1, but look at this. 0 questions. 0 questions done on July 16th. And now, just a little over a month, we're sitting at 204. Amazing. So, if you've all followed, like if we, does this tell us how long the playlist is? It'd be nice if it gave me like a total of like the length of the playlist. But you can imagine this is 45 hours, okay? I mean, 45 hours, you don't even have to do it in 45 days like I did, but you can do in 45 hours, you get to over 200 questions. And I promise you, there are a lot of easy questions that go under the rug and they're forgotten about, and people don't realize how helpful easy questions can be. So if you like this, if you're looking to, get better with LeetCode, as I know I have, and as I'm really hopeful a lot of you have, then go ahead and subscribe to the channel. Make sure you like the videos, ring the notification bell, do whatever you got to do. I will be updating the site. To be honest, I haven't updated the site in the last 2 days. It's just been like very busy at work recently. Haven't updated the site, but there's a ton of questions there for all you guys to do. There's a plethora of questions, so I don't suspect that anyone is done with all 87 yet. And if you are, I mean, kudos to you. If you want more questions and you're just like, man, I need more questions, then I guess in the meantime, until I get the community tab, open up an issue or something and be like, I need more questions. And that way I'll know. Anyway, thank you all so much for watching. I really appreciated today's stream. I think we tackled a lot of awesome, solid questions. So hope to see a lot of you all tomorrow. And I hope you guys all have a great rest of your Wednesday. Take it easy. Happy coding.